You're sitting at the kitchen table, enjoying breakfast, when your mom calls. She's excited because she just heard that taking a hot bath burns more calories than exercise. Or you're at work and a coworker forwards you an article. Weight loss pill, tested on pandas, now available for humans. Or you stumble across a newspaper headline announcing that fish oil supplements are now linked to having fewer friends. All the sources are supposedly reputable. Deep down, you're skeptical. But something inside you kind of believes this stuff, it's science and all. Or believes some of it, or just wants to scream. Let's face it, nutrition nowadays has problems. A lot of them. It's really hard to understand the headlines, let alone figure out what the best diet is, or whether red wine will protect your heart or kill it. Thankfully, there are strategies for making sense of it all. But to understand those, we need to recognize why nutrition science can feel so confusing in the first place. Then we can learn how to navigate the minefield wisely. Reason number 1. Nutrition science is really young. Relative to human life on Earth, the whole concept of nutrition, science, and doing things like juicing grass for health purposes is crazy new. Like barely out of the box new. Like wobbly first steps new. Like you're so young, can we even take you seriously new? And like any science, the history of nutrition is full of triumph, false starts, and epic fails. To give you a better idea, let's look at chemistry, one of the most mature sciences. Some 3,000 years ago, humanity started recording and manipulating metals. And a mere 1,000 years later, Aristotle, a Greek philosopher, declared that there are a grand total of 4 elements that make up all things, including these metals. Amazing. 1,000 years and the mysteries of life were solved. Except for the fact that we later learned there are actually 118 elements. Sorry, dude. And for the next 1,000 years, folks were focused on developing a surefire way to turn cheap metals into gold. Yep, century after century of alchemy. Thankfully, in the late 1700s, oxygen was identified, a huge discovery that led to an understanding of protons, electrons, atomic mass, and more. So, it only took 2,700 years to nail down a single chapter in your 7th grade science textbook. Now, here's the thing with nutrition. It didn't even start until the late 1700s, when Claude Berthollet discovered that the smell from decomposing animals actually has a name other than stinky vapor. It's ammonia. Step away from the dead raccoon, Claude. Then, in 1842, Justus von Liebig published a very influential book on nutritional science, despite having no real expertise in the subject. Hey, the first celebrity nutritionist, spreading the idea that protein was the only true nutrient. Maybe he was a bodybuilder. But thankfully, in the mid to late 1800s, there were big strides. Researchers discovered being on a boat in the middle of the ocean without fresh produce can give you diseases like scurvy. Will someone give that pirate a lemon? Then, the early 1900s brought the discovery of vitamins. A little later, DNA was discovered, and the fields of biochemistry and molecular biology emerged. So that was like yesterday. Which means nutrition science has only been around a minute, and researchers are writing in pencil, because knowledge is always evolving. And evolving means that we come up with stuff, think it's right for a while, disprove parts or all of it, and then come up with more stuff. It's, messy. As all things really young are. Kind of like my 1-year-old daughter. Reason number 2. Most of the money goes to disease prevention, not optimal nutrition. You could say that the developed world is dealing with a triage situation. More and more people are dying from cancer, heart disease, diabetes, digestive diseases, and kidney diseases. So both public and private funds get earmarked for potentially life-saving research, not, how creatine might get you swole research. Like, when was the last time you did a charity run to raise money for six-pack abs? Reason number 3. Nutrition studies are often funded by interested parties. Even when intentions are good, this can bias results. For example, among studies that ask, can sugary drinks lead to weight gain, those without financial conflict said yes, 83% of the time. Those with financial conflict, they got a yes only 17% of the time. And rarely is this outright fraud, although that happens too. It's just that studies can easily be designed to shine a light on potentially positive findings and look away from potentially negative ones, based on who's being paid to design them. Plus, if you were a sugar company, funded a study to prove it was safe, and that study came back suggesting otherwise, would you actually pony up and pay a journal to review and publish the findings? Or would you just leave them in a file folder in your research lab and hope no one ever finds them? Reason number 4, humans mess everything up. Okay, you knew this already. But when those humans happen to be participants in a nutrition study, total shit show. Variables like age, gender, health, genetics, stress level, sleep, how many weird diets you've done, it's nearly impossible to control for them all. Which means even in the best controlled study, it's hard to isolate the effects of nutrition from all the other factors that affect health. Even being part of a study can be a confounding variable, influencing the outcome independent of the treatment. Which makes it downright foolish to try to apply any study's findings to the entire population at large, or any individual within it. And hey, thanks for your service, little guy, but you're not a perfect study subject either. Reason number 5, people's memories suck. Since randomized controlled trials are challenging and expensive, most nutrition studies are observational. Researchers ask participants to fill out retrospective questionnaires about their eating and lifestyle habits. Quick, what did you eat for breakfast 2 Tuesdays ago? Or today's salad, was that 2 tablespoons of dressing or 3? And how many total reps did you do during last Saturday's workout? Exactly. Reason number 6, correlation isn't causation. Does red meat cause heart disease and cancer? Or do people with these health problems just happen to eat more red meat? Or is there some other variable, like overall health consciousness, that affects both our likelihood to grab a hot dog and to get a disease? Observational studies can't answer this. Oh, and while we're on the topic, did you hear about that one study that found a correlation between organic food sales and autism? Yep, the higher organic food sales in an area, the more autism. Does that mean buying organic food causes autism? Probably no more than putting up an umbrella causes it to rain. Reason number 7, calorie measures are super imprecise. When the USDA tells you there are 52 calories in your apple, that's actually just an average. And the margins of error are wide. 2 apples that are the exact same size can vary in calorie content by 20 to 30%. Packaged food nutrition labels can be off by up to 20% also. Similarly, while one person might burn 10 apples worth of energy during an hour of cycling, another may only use up 5 apples. In the end, our answers are only as good as the tools we have to find them. And right now, the tools we use for calorie consumption and expenditure aren't perfect. So even with a straightforward question like, how does calorie intake influence our weight? Any answer will be complicated. Reason number 8, health interventions take a long time to show effects. Remember how long it took people to realize how bad smoking was for them? Like generations? So eating extra broccoli for a few days isn't likely to cure you of your ailments. To firmly answer a big, important question like, does red meat cause cancer? You'd have to quarantine study subjects in a hermetically sealed metabolic chamber for at least 30 years and feed them various amounts of red meat. Who's going to sign up for that? And reason number 9, if doing the research is difficult, reporting on it is even tougher. Journalists often do their best, but most aren't trained scientists. This means that they often misunderstand study conclusions, over-exaggerate single findings, and don't see how single studies fit into the big picture. And sometimes editors, in an attempt to draw more eyeballs, create dramatic headlines that don't match the science at all. Truth is, while individual studies can be interesting, they're not often important. They usually provide, at most, one tiny piece of a gigantic puzzle that may take thousands of years to complete. I mean, thumbs up to the readers of those nutrition and fitness pubs for caring about their health. But exciting headlines and quick fix tips just aren't the solution. Yet here's what you can do. As you can see, nutrition science can feel complex, and firm answers about the exact amount of fat you'll lose or muscle you'll gain by eating X food just aren't happening. So feel free to ignore the headlines. Instead, do what nutrition scientists do. Look for larger research patterns that emerge consistently over time, like over 10 years or more across a variety of populations in a range of settings. Ironically, with all the fancy tools and research and big brains we have today, some of the most solid advice is stuff we've known for a long time. Like, eat a diet full of minimally processed plant and animal foods. Do routine physical activity with a mixture of low, moderate, and high intensities. Consume very little tobacco and avoid excess alcohol. Get adequate sleep, both quantity and quality. Find ways to control or recover from psychological stress, and cultivate meaningful, supportive relationships and social bonds. When looked at through this lens, while nutrition science may still feel confusing, your next steps are pretty straightforward. Thanks for watching and listening today. Just so you know, Precision Nutrition is home to the world's top nutrition coaches. We've been coaching clients and certifying professionals since 2005. Learn more at www.precisionnutrition.com.